Hello guys, how are you? So today we are the Thursday session of March 19, yani session 2. So last time we introduced the course and we did some conversion. As you see, we did the conversion between base 2 and base 10. We are following the course manual that you have on the screen. You can download it and follow it with me. As you see, this is it. Okay. I suggest that you download it and you use a pencil with you to add any comment where I am explaining. It will be a good idea. We are here now. Okay. By next week, we can begin asking questions. I will tell you how we can go online. We can use Zoom or WhatsApp as we see. I added a first student, okay, who just registered, okay, so you can follow me. So be sure to have the manual ready, very easy manual that you can use. Last time we did the conversion and I gave you a small exercise which is 317.5 to convert to binary and to verify. Okay, this is it. So how you do it, a fast explanation. You put the powers of 2. You have a 1 at 256 because you don't have a higher one because it will be 512 and 512 is less than 317. Then you as you saw previously, you deduct 256 from 317. Put a 1 here. You got 61. 2 power 7 is 128, you don't have. 2 power 6, 64, you don't have. 61 is less than 64. 32, yes, you have. 2 power 5, you put a 1, you deduct 32. You have 29. You have 1 for 16. You put a 1, you deduct. You have 8. You put a 1 and you deduct. You have finally 5. 4 here. You put a 1, you deduct. You still have 1. You don't have a 2. 5 minus 4 is 1. You don't have a 2, you put a 0. And finally you have your 1. The 0.5 is clearly the 2 power minus 1. So finally, your number 317.5 will be equal to what? Will be equal to 100111101.1 base 2. Okay, be careful when writing the number not to forget a 1 or a 0. Okay. You can verify quickly by adding the corresponding power. You did not make a mistake here or by subtracting. Okay, what you do is you add the powers of 2 where you have a 1. This is a 1, this is a 4, this is a 8, this is a 16, this is a 32. 64, no, you don't have. 128, you don't have. And you have 256. This one is the higher bit, yes, as you see. Okay. 32 and 8 is 40, 16 and 4 is 20. You have 60 here, 256 plus 60. You have 316 plus 1, 317, and this 0.1 is 0.5. Your number is correct. Okay? So now you must be good in converting from base 2 to base 10 and vice versa. Let's continue explaining the new part of the chapter. Okay? Now we will do some addition in binary. Okay. Okay, as we read here, the sum of two binary numbers calculating following the same rules as for decimal numbers, as in base 10. Okay. You want, for example, to do 15 plus 37. Base 10, what do you do? 5, you put them one under the other. 5 plus 7, you put 12. It's 12. you put a 2, and you put a carry. Okay, and you continue. So this is what we will do. Okay, هلا always, okay, we always add two numbers together. Suppose you have more than two numbers, you add two numbers, the result you added with the third number, and so on till you are done with the addition. Okay, so let's take an example. You have these two binary numbers, you have fractional part, decimal point, and so on. You put them one under the other, so the decimal point as you see, okay, you put the unit, okay, under the other. Here you can put a 0. Here you can put a 0. What does this mean? A 0 after the decimal point at the right is needless. You can add it because it doesn't have a value. But you cannot put a 0 here. You can put a 0 on the left of the whole number, like here. It doesn't have a value, but not in the middle or before the decimal point. Like in decimal, for example, 5, if you put a 0 here, it will be 50. Different. But 5, if you put a 0 here, it's still 5, okay? Sometimes I like to put zeros, especially if to write checks and so on, okay? But it's the same. So let's continue here and do the addition. After we place the two numbers, 1 plus 0 is 1. 1 plus 1, it is 0, and you have a carry. Okay, you have a carry. Okay? 1 plus 1 plus 1, it is 3. So you have a 1 and a carry of 1. Okay? 3 ones. If you add 3 ones, it is 1 1. 3. 1 1. You have a 1 and a carry of 1. Here. Okay. 1 plus 1 plus 1 also, it's 1 and carry 1. 1 plus 1 plus 0, it's 2. It is 0, carry 1. Okay? 0 and carry 1. 0 plus 0 plus 1, it is 0, also carry 1. 1 plus 1 plus 0, it is 0 and a carry of 1. Finally, the final one is alone. You just place it. So the idea is to add two numbers. You have either 1, 2, or 3. If it is 1, you put 1, no carry, or carry 0. If it is 2, you put a 0 in the carry of 1. If it is 3, you put a 1, a carry of 1. Very easy, no problem. Okay? For next time, you can practice on these two numbers. You have to convert to binary first, as we did previously, and you can sum. Finally, the final result you get in the summing, you can verify it is the sum. You do the sum in decimal, and you check and know your answer is correct. Do it as an exercise for next time. Okay? So next time I will solve this, to be sure and know you did it correctly. Okay? You can practice on other numbers if you want. So let's continue now. We are moving to another base. Now we go to two other bases, which are octal and hexadecimal bases. Why we need other bases? Base 10 is the human base. Base 2, or binary, is the computer base. There is no direct relation. The octal base, or base 8, oct it means 8, it has the property 2 power 3 equal 8. So directly, 3 binary bits will form an octal digit. What are the octal digits? The octal digits are like the decimal from 0 to 7. The octal digits from 0 to 7. I have 8 digits, 0 to 7, they are 8. So I don't have the digit 8 or the digit 9 that you know. Okay? So when you have a binary number, a big number, binary number, you can take 3 bits and you can convert to octal. يعني ساعتها each 3 bits will form octal digit. يعني if you have 20 binary bits, a number with 20 binary bits, you can divide it by 7. It will be how many? 7. Okay, 6 times 3, 18. Plus you have the 2 final, they will form a octal. يعني ساعتها 20 bits will be equal to 7 octal digits. So as we see here, the octal digits are from 0 to 7. Okay. هلا الoctal, how we do the manipulation. Let's do some exercises here, and to understand what's happening, let me take a paper. So the octal digits, so each 3 binary bits will form 0, 0, 0, it is 0 in octal. 0, 0, 1 is 1. 0, 1, 0, this is 2. 0, 1, 1, it is 3. Okay? 1, 0, 0, it's 4. 1, 0, 1, it's 5. 1, 1, 0, it's 6. 1, 1, 1, it's 7. Look, it is not by chance we ended directly at 1, 1, 1. For that, this is because 2 power 3 equal 8. Yani 8 combinations, as you see, if you count these combinations, they are 8. And here we have 8 digits. It will be exactly from 3 zeros to 3 1. For now, for example, our numbers that we did here previously, now we solved them. Yani 1 0 0 1 1 1 1 0 1.1. It was in base 2, and we found to be equal to 317.5 in base 10. What is this number in octal? What you do is to take 3 bits like this, okay, 3 bits, and here's 3. Hala. Here I have 1. What do I do? I can put zeros here. If here I didn't have a 3, I could write zeros on the left. Okay, but I need to start from decimal point and go left for the whole part and go right for the decimal part. If you don't have a decimal part like this, you start from here and you go left. 101, like here from the table, it's 5. 111, it is 7. 100, it is 4. Okay, you see the direct conversion. And point 100, it is also 4. So you can say, this is equal to 475.4, okay, in base 8. Hello, take care. I can say this number is 317.5. Look at the word 100. I am saying 317. Here I cannot say it is 475. No. It's wrong to say an octal number as it is spelled, because it's not 400, it is 300. This is an octal. So how I spell it I say this number, I say each digit alone. I say 475.4 base 8. Okay? Don't say 400. It is not 400. Okay? But suppose I have my number in decimal like this. I didn't have this. Can I convert directly to octal? You can, but it is difficult. You just pass by base 2. Okay, you pass by base 2, and from base 2 to octal, it is straightforward. Let's take a very larger number, 11011110111. Okay, 3. Okay, like this one, base 2. You directly put 7. You don't start from here, you start from here and you go left. Take this, it is 6. Take 6, it is 3. Here I have 2 bits. What do? You can add a 0 here on the left. This is also 3. So your number, your binary number, look how much it was it was big. Okay, now it is 3367 in octal. Okay. To convert this number to base 10, you can do the power of 2, or you can do, as it is explained here, you can do powers of 8. Yani you either add the powers of 2, to power 0, to power 1, to power 2, to power 3, no, to power 4, 5, 6, 7, 9, 10, okay? Or you can do powers of 8. How? You put, it is equal to 7 times 8 power 0, this is 1, plus 6 times 8 power 1, plus 3 times 8 power 2, plus 3, the second is 3, times 8 power 3. Okay? 8 power 3 is a big number. Okay? 8 power 3. Yani 8 times 8 times 8. Times 3 also. Okay? You need a calculator on to find it. And this is equal to this. And if you do the power of 2 or the power of 8, you will get the same result in base 10. Okay? If you don't get the same result in base 10, there is a mistake somewhere. Okay? For example here, 127.4, I cannot say 127, it is not 100, 127.4. Look here, it is saying 1 times 8 power 2, plus 2 times 8 power 1, plus 7 8 power 0, or plus 7 just, 8 power 0 is 1, plus 4 8 power minus 1. Also, I have negative powers of 8. What is 8 power minus 1? It's 1 over 8. 1 over 8, times 4, but it's here half, 4 over 8, يعني it's 1 over 2. Okay? Okay, as I am saying here, the digits 8 and 9 cannot appear in an octal number. Okay? But this is for octal. So, and for decimal, let's do now the hexadecimal base. The hexadecimal base, and we will see that hexadecimal is more important than octal. We are not stressing too much on octal. It's of lower importance. Hexadecimal is much more important. Okay? And we will see why. Hexadecimal is base 16. Why we are choosing base 16 just before 2 power 4 equals 16? What does this mean? It means 4 bits equal hex digit, hexadecimal digit. I have 16 digits, hexadecimal. What are my hexadecimal digits? Okay, look here. I can use the 10 digits from base 10, which are 0 to 9. هيدول 10 digits. طب I need more. What are the other digits? By convention, standard, we are using the letters A to F. A, B, C, D, E, F. Here, A, B, C, D, E, F are not letters. These are digits. Okay, they represent digits. For the values 10 to 15, اللي هن in base 10. Now, we will see numbers where you have digits, like 0, 1, 2, and you have B and F. For example, if you take this number, B65F in base 16, you want to convert it to base 10. What to do? B is 11. لأنه A is 10, B is 11. 16 power 3. Why 16 power 3? لأنه here power 0, power 1, power 2, power 3. 11 times 16 power 3, this is very huge. Plus 6, this 6, times 16 power 2. Plus 5, this 5, times 16 power 1, plus 15. The F here is 15, the last digit. Okay, 16 power 0 is 1. Anything power 0 is 1. You add all these and you got 46,687 in base 10. Okay. Okay, طبعا in base 10 you have digits only from 0 to 9. Okay. Let me here do some computation in base 16. What are the digits? Let me write them for you. So 0000, each 4 bits. هذا الهexadecimal. Okay, 0001, it's 1. You see 0010. Look here, if you compare, here you had 3 bits forming an octal. Now here you have 4 bits forming a hexadecimal. Okay, 0100. For fast writing, what I can do is to write this, okay? Sorry. بس انه take care not to make a mistake. I had 1 0 1 0 1 0 1 3 4. Okay. 5 6 7. هلا you put 1 1 1 1 1 1 1 1. هلا if you are on your the paper, okay, to avoid having a problem, 4 zeros, 4 ones here. نرجع 2 zeros, 2 ones, 2 zeros, 2 ones, 0 1 0 1 0 1 0 1. You have 8 9 A B C D E F. Okay, is this stable? What does this mean? As you see, you have the 16 combinations from 4 zeros to 4 ones, from hex 0 to hex F. Okay, now take back this number. Let me take another color. I have red, for example. I want to convert this number and this number to base 16. Okay. So what do you do here? You take 4. 1101. It's what? 1101. It is D. 1100 is 3. And you have finally a 1. You put 3 zeros on the left, it is 1. So this is equal also to 13D. Point 1, you put 1000 is 8. Okay? So this is your number in base 16. Okay? You see you have a D. A D here is a digit. For this one, you take 4. Take 4. Take 4. This is 7. 0 1 1 1, it is 7, as you see here. 1 1 1 1, it is F. Okay. 0 1 1 0, I added a 0 here. This is 6. So this is equal to 6F7 in base 16. It is equal to 3367 in base 8. Okay. Come in. You can do the power of 16. Okay. Equal to find it in base 10. You can do it in base 2 to base 10, base 16 to base 10, or from base 8 to base 10. You will find it. You must find the same number in base 10. Okay. We saw here how this is. I will go over here. What do I have here? Okay. For example, look at this big binary number. I convert it to octal by putting each 3. I did some separation just to show each 3 bit. It will be easier for converting. When I'm converting to base 8. If I wanted to convert to base 16, I did it here. Yeah, it is done in base 16 here. Okay. كمان هون I did it. I placed my numbers 4 bits in groups of 4 to make conversion easier. Okay, this is the table. We'll see the table. هون conversion easier. Then you put each hexadecimal digit for each group of 4 bits. Okay, if you compare base 8 and base 16, sorry, ضربنا بالتليفون هون. If you compare base 8 and base 16, what you can see is the number in base 8 or octal is still a little bit larger than base 16. Here I have 4 digits, and the whole part here I have 5. Why? Because of course I have more digits in base 16. It's a larger base. Base 16 is still more compact than base 8. This is the first advantage. Another big advantage of base 16 over base 8 is, as I am saying here, in memory, memory bits or the values in memory are in terms of bytes. A byte is 8 bit. أو بقولوا له كمان octet أو byte. طيب you see 8 bits. 8 is a multiple of 4. each 4 bits 4 bits بيعملوا 8 bits. each 2 hexadecimal digits will form a byte. But for the octal, you have 3 bits for octal. 3, 6, 9. 3 is not a divisor of 8. Okay? So you have a problem when converting in memory the values if they were in octal. But if they were in hexadecimal, it's very easy. Each 2 hexadecimal are equal to 1 byte. For that, when you go later on in dumping memory in advanced computer courses and networking, you will see all values in hexadecimal. Each 4 bits in binary are equal to 1 hexadecimal digit. And for a memory byte, you will see 2 hexadecimal digits. You will see this later on. Okay? Here, what I did here, the paper, sorry again. What I did here, this is here, 0 to 16, as you see, the binary. Okay, as you see, 15 is 1111. If I want to 16, it will be about 10000. This is 16, and this is the 10 in hexadecimal. 10 in hexadecimal is 16 in decimal. Okay, 10. This is not 10. In hexadecimal, 10 is 16. You see? 10 in octal is 8. 10 in binary is just 2. You see? When you say the base, you have to specify the base when you say the digit. And you pronounce the number. Here only I can say this is 10. Because it is in base 10. Okay? Here I cannot. It is 10. Here it is 10. Here it is 10. It's a different 10. Okay? Here, okay, the 10 in base 10, you can say it 10. Okay? طيب. Let's do still the final part for today. I am doing in one session. We are around still less than half an hour. Now I want to do some octal and hexadecimal addition. Okay. We did binary addition. Base 10 decimal addition. Let's do now the octal and hexadecimal addition. And finally, what we will do is to add different bases, numbers. We have to convert to a same base, okay, to a common base, and we then do the addition. You can never, remember that, you can never add 2 numbers in 2 different bases. You must have the same base, regardless what is the base, in base 10, in base 2, in octal, in hexadecimal, but you must add 2 numbers in the same base. If I want to add in base 8 2 numbers, what I do, mentally, I add the 2 digits in base 10. For example, I have a 5 and I have a 4. 5 plus 4 is 9. But 9 is greater than 8 in base 8. So I do a subtraction. 9 minus 8. Okay, I got 1 and I have a carry of 1. If I am adding 2 plus 3, okay, 2 plus 3 is 5. 5 is a digit in base 8, it will work. Okay? نفس الشيء in base 16, but in base 16, you don't forget the A, B, C, D, E, F. For example, 5 plus 8, it is 13. 13 is what? It is D. Okay? It is D. When you put a carry, when you are above 15, 16 or more, for example, you are adding 8 plus 9. Okay? 8 plus 9 is 17. 17 minus 16. You put a 1, a carry, and a carry of 1, as we will see. We need to do some exercises. Okay? Let's do the exercises here. Okay? And we will give an exercise for next time. For example, هون okay. هون I think انه صار دافش from هيدي ال1 هيدي ال8 يعني لازم تكون okay from another part يعني okay okay we have 4 5 6 2.7 and 317 sorry put 317.42 42 not 42 يعني it is wrong to say 42. It is not 42. You put the digits one below the other and you add 2 plus nothing 2 or 0 يعني here you have a 0 here you have a 0. 7 plus 4 mentally it is 11 above 8. You do mentally 11 minus 8. It is what? It is 3 and you have a carry. Okay? This is the 3 here. And you have a carry. You add 7 plus 2 plus 1, it is 10. 10 minus 2, 10 minus 8, is it above 8? It is 2. You put a 2, as you see here, and the carry of 1. Okay? 7 plus 6, 13 plus 1, 14, come in above 8. Okay? Don't forget. انتبه هون نو سوري 7 بلس 2 هيدا عملناه 6 بلس 1 شفتوا هون لانه زحتها شوي هون كان رح نوقع بمستيك 6 بلس 1 7 بلس 1 8 8 is exactly 8 so 8 minus 1 I have a carry why because 8 minus 8 I put a 0 and I have a carry you have a 0 here you see the 0 5 plus 3, 8 plus 1, 9, minus 8, you have a 1 and the carry of 1, 4 plus 1, 5. Okay? I will repeat it. So 2, 7 plus 4, 11 mentally. Written, you put minus 8, you have a 3 and the carry of 1. 7 plus 2 plus 1, 10, minus 8, 2, carry of 1. 1 plus 6 plus 1, it is 8, minus 8, 0, carry of 1. 5 plus 3 plus 1, it is 9, minus 8, 1, carry of 1, 1 plus 4, 5. Okay, this is 0. So your addition, this is it. Now let's do an addition in base 16. You have two numbers, then is this number and this number. يعني you are adding what 6 5 D 9 7 plus هوني هيدا big number 4 B 7 B 8 E Oh, very huge. Okay? Very huge. You don't care. As much as it's huge, you don't care. Okay? 7 plus E. What is 7 plus E? What is E? E is 14. E is 14. You need to know. Okay? E is 14. E is 14. You have to memorize this. 14 plus 7, 21. It's above 16. 21. So here I have 14 plus 7, 21. Minus 16, you have a 5 and the carry of 1. So when you add in base 16, you have first, if you have a digit from A to F, convert it to base 10 mentally. Now 1 plus 9 plus 8, 9, 10, 18. Come in above 16. 18 minus 16, you have a 2 and a carry of 1. B plus D plus 1. قالكم أنا أرقام كبيرة. B plus D plus 1. B is 11. Remember, A is 10, B 11, C is 12, D is 13. يعني 13 plus 11, 24, plus 1, 25. 25 minus 16, you have a 9. And a carry of 1. كبيرة هيدي. هلا you can repeat this, يعني you can view it another time. Now 1 plus 5, 6 plus 7, 13. 13 is below 16. So we'll have a digit only. 13, what is 13 hexadecimal? Is just D. And you don't have a carry. You don't have a carry. Finally, here, B plus 6, B is 11 plus 6, 17, minus 16. You have a 1 and a carry of 1.